In path-independent changes, it doesn't matter how you get from point A to point B. The distance between the two is all that matters. And that's how things work in thermochemistry with energies. Now, suppose we talk about burning things. One of our favorite topics in chemistry, right? And suppose that we start out with octane and oxygen. Now, there's two ways that we can do something with octane. One would be to simply light the thing on fire. All of that energy would be lost as heat. And we'll assume that there's no work being done, although I'll point out that if you hear any sound, that means that there's a volume expansion. That means you're moving things around. And you're going to hear that. That also means that we are doing a small amount of work. But in a perfect and ideal scenario, we can describe it as if there wasn't any. We can picture that nearly 100% of that energy would be lost as heat, right? However, if we're more careful, we can try to minimize the amount of energy going into heat while maximizing the amount of pressure volume work being done. In other words, making it do work by creating pressure or by making volume changes. That means that we're going to be converting some amount of that energy into work. And yes, some of it's still probably going to end up as being heat. If we had a perfectly efficient car engine, and we are converting octane into carbon dioxide and water through a combustion reaction, with absolutely no loss into heat, that would be the maximum efficiency we could ever get from that gasoline. However, anytime that we start using some as heat, some of it's going to be turned into heat, we're going to have less of it being turned into work. The efficiency of the vehicle will be less. Now, let me point something important out about that. It does mean that we can't have a perpetual motion machine powered by gasoline or any other process because everything in energy is going to be path independent. So no matter what, there's going to be a finite amount of energy that's available in the fuel. What you can do is convert it as efficiently as possible into work. And you can even do some clever tricks to try to maximize the amount of work being done and the usefulness of that work. But you're still going to have some finite amount of energy that you can convert into work. So there will never be a perfectly efficient fuel or some sort of a perpetual motion machine. There's always some sort of a theoretical limit to how useful the fuel can be. And then on top of that, there's going to be practical limitations for how you're doing those conversions. And that's what the engine manufacturers are dealing with as they try to make better, more fuel-efficient vehicles.